So I have to first qualify this by saying this work was not my idea, nor I didn't do any of it. This came from Bill Durnell, who actually left. He's the department chair at Clinical Science at Washington State University now. So I took this over about a month ago. So you're going to hear my spin on Bill's work. So, okay. So what we're going to be talking about today is the evaluation of lymphatic drainage and uptake following intracavitary chemotherapy administration for mammary carcinoma. And this is Bill's title, and I'll try to simplify it a little bit. What we're really going to be talking about is if you put a drug, a chemotherapeutic agent, in the tumor bed after removing it. Where's the clicker part?
You talk, I'll see if I can figure it out.
If you put, what this really says is if you put chemotherapeutic agent into the tumor bed post-surgically in breast cancer, what happens, and does the drug actually move through the lymphatic system? And we're going to talk about why that might be advantageous for therapy and how that might help. So the basic point is that when you think about the lymphatic system is a secondary circulatory system in the body that runs right adjacent to the vascular system. And the role of the lymphatics in biology and in physiology is that it removes fluids from tissues. So it's kind of a drain that can take fluids out. It also absorbs and transports lipids. And it plays a role in defense via lymphocyte activity. So they're called lymphocytes, B cells and T cells, which are immune cells because they hang out in the lymphatic system. And the idea here is that can you have drug movement through this circulatory system, and can that help benefit you in terms of drug therapy for cancer post-surgically? And there's some reasons to believe that it would. One is that cancer cells spread throughout the body by utilizing the lymphatic system as a mode of transport. And this is a mechanism of metastasis. And we know this because the presence of cancer cells in lymph nodes close to the primary tumor sites is a major determinant of disease spread and patient prognosis. And so one of the first things you'll hear when a woman's diagnosed with cancer is whether it's node positive or node negative. And what they're talking about there is the presence of tumor cells within these nodes near the tumor bed. So the major questions that the major problems that we're going to be addressing is that breast cancer spreads via the lymphatic system to other parts of the body, that cancer chemotherapy is generally delivered via IV injection into the blood. Thus, these cells that are in the lymphatic system may not get exposed to high enough drug levels to be killed. So the point here is that after you cut out a tumor, you do still have residual disease. We know that. That's why we give chemotherapy at that point, and that the cells within the lymphatic system may not be susceptible to the drugs that are given just based on the drug being in the blood and not getting good delivery to the lymphatic system. Okay, so the questions that we decided to ask are, would increased drug delivery to the lymphatic system increase the efficacy of chemotherapy after surgical resection of the primary tumor? So can you increase drug delivery to this area after surgical resection? And this is within the process of how the disease is usually treated. Usually cut out the primary tumor and then deliver the drug. So can we increase delivery through the lymphatics? And will chemotherapy delivered in a slow leaking gel to an intracavitary space? And what this means is tumor bed. It's the cavity where the tumor was removed. Can you put a gel with drug in it in this space and have this drain kind of where the tumor would drain through the lymphatic pathway, basically chasing those tumor cells through the lymph and chasing them down? So we tried to explore that by this series of experiments. Okay. Now, the drug formulation that we used, and I have a strong chemistry background, so everybody has to look at a structure. This is Taxol, so it's not as bad as some of the laser stuff, but this is in fact a drug. This is Taxol. It's a natural product, came from the Pacific yew tree. Taxol is actually the registered product. Its generic name is paclitaxel. It is used in first-line treatment of ovarian cancer and breast cancer and a whole series of other tumor types, kind of a broad spectrum drug at this point. What we did is we mixed it with a polymer, a poloxamer that was biodegradable and thermoreversible. So you can mix these under cold conditions and they're fluid, and as soon as they start to warm up, it forms a nice solid gel. And so that was called by Bill, not me, Politax. And the point is it kind of sits here like a gel, and the little Taxol molecules kind of slowly leak out, okay? So that's the idea. Can post-surgically in the tumor bed, we put this polymer with the drug and have it slowly leach out, chasing down the cancer cells through the lymph. So this is some initial tumor response data. What this experiment shows is we put MCF7, which is a human tumor cell line, that are transfected. Basically, we put a firefly tail in these tumors. They have luciferase, which is the same thing that makes firefly tails light up. And this allows us to image this in a camera, a special camera that we have, so we can actually look at tumor growth in the animal. These animals are not dead, they're just sleeping, okay? So you can look at them, you can see their little noses and a nose cone there. You can follow these over real time and look at metastatic spread and tumor growth. So we have, the tumors were put in these animals in the mammary bed, which would be around here for a mouse. When they got to about 500 millimeters cubed, which is fairly large for a mouse, they were resected, as they would be in a human patient. And then at the tumor bed at this intracavitary site, we either put Polotax here in A, control, which meant they got nothing, or poloxamer alone, just the poloxamer stuff without the Taxol added. Or we put Polotax at a remote site, so actually we flipped the mouse over and put it between their shoulder blades, so distant from the tumor bed. Or we gave the standard of care, which would have been Taxol via an intravenous route, and this was given by the tail vein. What you can see here is there's little spots here because we had to leave these guys under the camera for a while because nothing showed up. So the ones that were treated at the surgical site with the Taxol polymer, there was no tumor regrowth. The controls, you see the glowing firefly tail here, which tells you that the tumor regrew here at the resection site. Here, if we put the Polotax at a remote site, actually we got metastasis to the lungs. So you can see the tumor starting to spread to the lungs, which is where you would expect it to go via the lymphatics. And by IV Taxol, we could keep this guy small, but you can see there's certainly tumors regrowing, and which is not a good outcome. If we look at this tumor response over time, you can see that in the controls, basically all the animals had tumor regrowth at the primary site. The poloxamer alone basically gave the same response with no Taxol. If you gave the Polotax here, you can see that there's nothing for the first 40 days, and after 60 days, about a quarter of the animals started to have regrowth at the primary site. What's important to note is that this is after one treatment. We very easily could have given multiple treatments. There was no toxicity, no side effects, no weight loss. The animals were fine. The Polotax at a remote site, we had about half the animals have regrowth, and you can see that IV treatment, all the animals regrew at 60 days. Less encouraging, the metastasis data in all of the animals at 60 days, we did start to see distant metastasis, as with the lungs or somewhere else. So the single treatment, although we had more or less excellent local tumor control, the metastasis were not altered, although they did show up slower with the Polotax than they did with some of the other therapies. Okay? And again, this is just an initial series of experiments. The next question, so that's the answer to the first question. Does this Polotax given in the tumor bed control tumor regrowth? The answer is yes. Does it stop metastatic spread? Not as well as we'd like it, although it certainly did slow it down a little bit. So the next question was, can we track this drug moving through the lymphatics when we give it in an intracavitary site, or does it just spread around? And to illustrate kind of how these experiments were done, here are some pictures that Dr. Robert Boone, who's a DVM PhD resident who's finishing up in the Animal Cancer Center, helped us with. His PhD work was on the lymphatic transport of colon tumor cells. So Rob had done a lot of these studies and showed us that if you inject methylene blue here subcutaneously in the ear of a mouse, it drains to this mandibular lymph node. You can see it showing up blue, and actually then to the inguinal lymph node. And you can see here the lymph system here is all blue, and this node is turning blue. You ask why we even care. Well, what this allowed us to do was we injected Taxol here in this ear, and then we could go sample these lymph nodes to see if the drug actually went there and transported there or just spread out all over the place. So we did that, and we measured the Taxol by mass spectrometry. That is something that I did do, so I was involved. We did do the drug measurements, so this I know. So when you look at the lymphatic transport, you can see that the right inguinal lymph node did accumulate the Taxol very quickly. Here's plasma, so this would be systemic exposure in the body. And you can see the left node didn't have a lot of drug, but you can see it did accumulate some drug. The other important thing to note here is that the measurements in plasma are per mil. In the nodes, this is per milligram. A milligram would be about 1,000th of a mil. So the levels in the lymph nodes are a lot higher than the plasma, really by about 1,000-fold. So the drug does seem to stay in the lymph and doesn't distribute all over the place when we inject it subcutaneously. So that was the first experiment. And the conclusion is Taxol does travel via the lymph and doesn't go wandering around all over the place. So the next question is, can we take our Polatax gel, so our gel with Taxol in it, put it in the mammary fat pad where we had put it in the animals for the therapeutic study, and where does it go? Here, we decided we'd also sample the fat to see if it just, around the lymph nodes, to see if the drug just distributed into the fat and got into the lymph nodes, or if it was actually traveling via that lymph flow. So here's the right inguinal node. These were put in the right side. Here's the right fat here in the yellow. And you can see that the drug does maintain higher levels over time in the lymph node. This is about 10-fold. This is a log scale. So the drug does stay in the lymph node. Certainly, again, these are about 1,000-fold elevated over the plasma if you look at them. So the plasma levels are lower. And both the left and the right lymph node stay above the regional fat. So this Polatax administered in the right mammary fat pad also seems to stay in the lymphatic system rather than just kind of go hairy-nary and yarn wandering around. Okay? So in conclusion, locally delivered Polatax leads to increased local tumor control. Taxol is transported via the lymphatic system, and this intracavitary Polatax accumulates in the lymph nodes, preferentially to fat tissue, suggesting trafficking through the lymph. So I think it's safe to say that this set of experiments has given us some good insight into how these types of gels and drug formulations might be utilized post-surgically, and they certainly, it was pointed out, I hadn't thought about this, but I think this was kind of one of Bill's original ideas, in areas where you don't have radiation or can go get common chemotherapy all the time. In third world countries, you can maybe use these gel implants post-surgically in women with breast cancer surgery where they can get surgery and have local disease control. So there's a lot of promise, a lot of development that needs to go in, but the preliminary studies suggest that we can traffic these drugs through the lymph and show some promising therapeutic benefit. So acknowledgements, this is Bill's work, his idea and work, and Laura Chubb, Joanne, I always screw this up, Tui, she's a second-year DVM student who worked on this. Rob and Brad, who actually does work in my lab and did all the drug analysis. And with that, I will certainly take any questions about this.